Alrighty then, now it's time for another single sample test, the single sample t-test. Again, single sample means you're comparing a single sample to an overall population. In the case of the t-test, the big difference is that the sample size is less than 1,000. So let's use this example from the lesson where we have Bob Jenkins, who's a sports trainer, and he believes he has this new dietary supplement that he's experimenting with on the 25 athletes in his care. And he thinks it's going to increases their performance. He thinks it will significantly increase their performance. And he wants to compare it with all other similar athletes' performance records. So that's a population of athlete records. So he's comparing a single sample of 25 to all the other athletes in the world. It's a classic single sample t-test. As you see here, the formula is just about exactly the same as in the z-test. We use the mean of the sampling distribution instead, but we know that the mean of the population approximates the mean of the sampling distribution. And so when that's given to you in the problem, you're given the means. The mean of the sample, 14.11, the mean of the population, 13.56. Then we have, remember, the standard error is simply s over the square root of n. So we have s, which is given to you in the problem, 0.52, and the sample size is given to you, square root of n. So we do the math. The numerator is 0.55. We end up with 0.52 divided by 5, which is 0.11. 0.55 divided by 0.11 comes out to 5. So t, the t value is 5.00. So from here, in order to determine if it's significant, we have to go to the t-test. And before we go there, we're going to calculate the degrees of freedom. So for this formula, it's just n minus 1. We have a sample size of 25, so the degrees of freedom is 24. Now we know that Bob Jenkins was always also predicting direction. He was predicting that his athletes would have higher performance. So that's another one-tailed test, predicting direction. So if you go to the table, look under a one-tailed test, under 0.05's level of significance, with degrees of freedom of 24, you find a critical value of 1.711. And since our calculated t-value of 5 surpasses 1.711, we say that our results are significant. This dietary supplement that Bob Jenkins has created does significantly increase performance in athletes. That's an example of a single sample t-test.